Hi, I'm Dr. Jim Zoval, a professor of chemistry at Saddleback College. You're about to watch one of my video lectures. If you like this lecture, you can get the entire Allied Health General Organic and Biochemistry course from the website address you see on the screen right now. Be sure to type the underscore between VOD and pages in this address. Enjoy the video. The next chapter introduces us to some more organic compounds. And we do the same thing we did with our other organic compounds. We say, what are their structures? How do we name them? What are their properties and how do they react? We're going to start off with alcohols, ethers, and related compounds. I'll talk about what I mean by related compounds. You have been introduced briefly to alcohols already. Remember what an alcohol is? You have an organic group attached to a hydroxide group, an OH. Here's an example, a specific example of one alcohol. The organic group is the ethyl group here. Here's the ball and stick model. Remember, this cloud shows us where the electrons kind of hang out. Some of these are highly polar bonds. When it's bright red, that means that's really a negative, partially negative side of the molecule. Where it's blue, that's partially positive. That's because of these highly polar bonds over there. Where the hydrocarbon part is, notice it's kind of a green color. The electrons aren't polarized there. That's the nonpolar part of the molecule. Some commonly seen alcohols, wood alcohol. If you heat up wood, you see a liquid come out of there. You guys might have done that in your science class. That is methanol, the common name methyl alcohol, sometimes used in fuels. Ethyl alcohol is something different. Enough said with the picture there? You've heard of isopropyl alcohol or rubbing alcohol. The systemic name of that is 2-propanol. Some alcohol molecules have more than one hydroxy group. Glycerol, for instance, has 3 carbons, and each of those carbons have a hydroxy group. We call that a triol, 3-all alcohol group. This stuff acts as a lubricating fluid in eye drops. To name an alcohol, you're going to find the parent chain. The parent chain will be the longest continuous chain of carbon that has a bond to the OH. In other words, the OH necessarily is attached to the parent chain. We distinguish it as an alcohol versus, say, an alkane or a carboxylic acid. We'll remove the E from the alkane name and replace it with OL. We're going to number the parent chain. Carbon number 1 is the carbon that's closest to the hydroxy group, just like you did with amines. Remember with amines, carbon number 1 was the carbon that was closest to the attachment to the nitrogen. When there's more than 2 atoms, we have to put a number in front of the parent chain, just like we did with amines, to signify the position of the hydroxy group. And then when you have substituents, alkyl group substituents, you put them out in front of the parent chain name in alphabetical order like we did with the other organic compounds. Some examples. 2 carbons, ethane. We get rid of the E and put OL, ethanol. Now, we don't have to say 1 ethanol because there's no such thing as 2 ethanol. If the hydroxy group was here, that would be 1 ethanol. And we don't need to put a number in front of methanol when there's just 1 carbon because there's just 1 carbon. 1, 2, 3 carbons. Hydroxy's on carbon number 1, 1-propanol. Here's 2-propanol. So these molecules have the same molecular formula. They have the same number of carbons, same number of hydrogens, same number of oxygens. They differ only in the connectivity. These are constitutional isomers. Different molecules, we need a different name. They have different melting points, different boiling points. So one may help you, one may kill you. Either one will kill you if you drink enough of them. But notice in this one, the hydroxy group's on carbon 2, so that's 2-propanol. The common name is isopropyl alcohol. Very often small alcohols have common names by naming the group that's attached to the hydroxy as a alkyl group. So right, that would, notice the attachments to the middle here, that would be isopropyl. Right, this looks like, if that was a parent chain, that would be an isopropyl substituent. That's how they do the common names. Up there, it's propyl. Try one. Name that compound. Write the name down. If you're watching the video, click pause and do this problem. Okay, we got it. What's the parent chain? We can either say that's the parent chain, or that's the parent chain, or that's the parent chain. They all give you the same name, so let's do the easiest one. We'll say that's the parent chain. 1, 2, 3 carbons, so propane is the alkane name. Get rid of the E suffix and put OL on there. Propanol, we need to put a number in front of the parent chain to indicate the placement of the hydroxy group. That's on carbon 2, so 2-propanol. And we have a substituent on the parent chain, and it's on carbon 2, so 2-methyl-2-propanol. When we spoke about amines, when we talked about their structure, we saw how there were 3 different types of amines: primary amines, secondary amines, and tertiary amines. We're going to see a similar thing with alcohols. Let me remind you about amines. We had primary, secondary, and tertiary. Primary, secondary, tertiary amines. Whether it was a primary amine, a secondary amine, or tertiary amine, they all had this in common. A primary amine has 1 organic group bound to the nitrogen and 2 hydrogens. A secondary amine has 2 organic groups bound to the nitrogen and 1 hydrogen. A tertiary amine has 3 organic groups bound to the nitrogen. And remember, because this one does not have an NH bond like these do, this one is unable to form hydrogen bonds with other tertiary amines. There's a similar thing we do for alcohols. In a primary alcohol, the carbon atom carrying the OH group is attached to 1 other organic group. So instead of looking at how many organic groups are attached to the nitrogen, like we did with amines, we're going to look at how many organic groups are attached to the carbon that's bound to the hydroxy group. Let me draw that and show you what I mean. I'll draw just the general form. Here's a specific example of a primary amine. Notice this hydroxy group is bound to that carbon. How many R groups is this carbon bound to? 1 and 2 hydrogens. So just like amines all had the nitrogen with 3 bonds and a lone pair in common, alcohols will all have this in common. We call them an alcohol because there's a carbon with an OH attached to it, right? Now, this carbon will have 3 other bonds going to it. So I'll just do this for each of the cases, and then we'll look at the difference between primary, secondary, and tertiary alcohols. I'm going to circle the carbon that's carrying the OH, just so we can keep track of it, is that one. Up here we kept track of what was bound to the nitrogen. Here we keep track of what is bound to the carbon that's carrying the OH, or that's bound to the OH. And it works the same way. In a primary alcohol, the carbon that's carrying the OH is bound to 1 other organic group. Another way of saying that is the OH is on the end carbon in the parent chain. In a secondary alcohol, the carbon carrying the OH group is attached to 2 other organic groups. Notice here, carbon that's carrying the OH, 2 other organic groups, and 1 hydrogen. So the general form for a secondary alcohol is this. Let's circle the carbon carrying the OH. Yes?
What is that dash by the R?
This dash, we call that, so we call that R with no dash, no apostrophe, we call that R. We call that R prime. That indicates that these organic groups are not necessarily the same. If it was just R, you might think, well, if this is a methyl, that has to be a methyl. So we put a little mark on there that shows this organic group is not necessarily identical to this organic group. For example, this one could be methyl, and that one could be ethyl. Or this one could be methyl, and that one could be isopropyl. Or this one could be methyl, or this could be some long branch thing. That R means that that group is not necessarily the same as that one. It could be, but not necessarily. That's why I had to put double prime over here, because they all 3 could be the same, or 2 of them could be the same, and 1 of them could be different, or they all 3 can be different. I think you're seeing the pattern. A tertiary alcohol, the carbon carrying the OH, this one, is attached to 3 organic groups. R, a second one we'll call R prime, and a third one we'll call R double prime. Here's an example. Notice the common name is T-butyl. That's terse-butyl. You probably haven't seen that too much yet, but if you look way back in chapter 4 when it gave the list of all the alkyl substituents. I told you I want you guys to know from butyl up. If you look at some of the ones under that, this is T-butyl. It's butyl because there's, in the substituent, there's 1, 2, 3, 4 carbons, and T stands for tertiary because look, this carbon is a tertiary carbon. On the exam, you'll have at least one problem that's going to ask you to identify a primary, secondary, or tertiary amine, and you'll have at least one problem that's going to ask you to identify a primary, secondary, or tertiary alcohol. Furthermore, for alcohols, we're going to see in later sections of this chapter, the reactions that alcohols undergo are dependent on whether they're primary, secondary, or tertiary. So it's an important point. Hi, I'm Dr. Jim Zoval. If you like this video and you'd like to get the entire course or just some of the chapters on video, I have the entire course in video lectures at the website you see on the screen right now. They're available on demand. The period of the rental is for a full year, so you'll have this video through the entire course. You could watch it as many times as you want, whenever you want. Happy studies.